Hello all. So from this lecture onwards, we will start programming language C. So in this lecture, we will see about an introduction to C language. Then we will see about keywords and identifiers. So this is the outline of this lecture. We will see an introduction to this C programming language. Then we will see the general structure of a C program. Then we will see what is a token. Then we will see what is the importance of the semicolon. Then we will see comments about Whitespace and also keywords and then about identifiers. So C programming language. So it is a general purpose programming language. So this means we can do any kind of programming in C language. If you want to develop some high level applications, so if you want to develop some embedded programming kind of thing, all these things are possible when you do this, when you use the C programming language. So it's a general purpose programming language, and it is a procedural oriented language. So you'll learn about this programming paradigms in later semesters. So there you will see the different programming paradigms like procedural language, imperative language, then object oriented language. Like that, there are different types of programming paradigms. So C is a procedural oriented language. That means there are some procedures, we'll have some procedures and we will call those procedures, and those procedures will be executed and something will happen inside the procedures like that. So when you learn more on C, you will understand what is meant by this procedural oriented programming. Then it is an imperative computer programming language. So what do you mean by this imperative programming language? So in English language and all, when you say some sentences and all, you know that there's an, you call it as an imperative sentence. For example, get out, it's an imperative sentence. It is actually a command, or it is something, we call it as an imperative sentence. Or go away, like that. If we say some sentence, it is known as an imperative sentence. So similarly, in C language also, C programming language is also considered to be an imperative programming language. That is, we will have some commands. So we will have some statements. Based on that statements, it will change the state of the program. So based on the statements, the program will change its state. So if we say get out, so some person will go out of the person's mood will be changed or state will be changed and he has to go out. So similarly, C is also a imperative programming language in the sense that it has some statements where those statements when executed will change the state of the program. So it was developed in 1972. If you go into the history of C programming language, C was earlier developed for Unix operating system. So earlier there was Unix operating system, and Unix operating system was developed in assembly programming language for PDP 7 machine. PDP 7 machine was there, and for that they Dennis Ritchie and Ken Thompson developed that Unix operating system in assembly language. But then a new system came, PDP 11. So they decided to port that operating system to that PDP 11 system. And again, that PDP 11 system, also that Unix operating system, was developed using this assembly language. So Thompson, this Ken Thompson, so Dennis Ritchie and Ken Thompson were the persons who developed this assembly code for this Unix operating system. So Thompson wanted a programming language such that he can build new utilities into this Unix operating system. So he initially tried with Fortran compiler, Fortran programming language, but it didn't work. So he developed a language, BCPL, systems programming language. We can call it as B language also. And it was not at all, he used it for some time. But Dennis Ritchie, what he did was he modified that B language, and he developed some more features such that more features will be supported like that. He developed a new language called C language in 1972. So it was initially Dennis Ritchie who improved that B programming language, and it resulted in a new language called C. Okay, so then later the version 4 of Unix was released in 1973, and it was implemented in C programming language. So earlier Unix versions were developed using assembly code. Now, when C language came, they developed this Unix version 4 operating system in C programming language. And later, most of the Unix systems were developed in C programming language. And in 1978, they did this Dennis Ritchie and Brian. They together published the first book of for the C programming language called the C programming language, and then only the people came to know about the C programming language. So it was in 1978 people started using the C programming language. So it was initially developed by Dennis Ritchie, and they published this book. And this is actually Dennis Ritchie, and this is Ken Thompson. So these were the persons. So he initially developed B language, and based on that, he developed Dennis Ritchie developed this C compiler and all. So now there are various versions and various compilers for this C. So if you can refer some history of the C programming language somewhere. We need not go through all the history and all this lecture. So we will come to the structure of C programming, structure of a C program. So this is a C program. This right hand side column denotes a C program. So we have mainly these components in a C program. One is preprocessor commands. So this is an example for this preprocessor command. So preprocessor command starts with hash. So hash include stdio.h. We will see about this later. I just want to introduce the structure of the C program. Don't worry about all the details of this, what is this hash include and all. Anyway, preprocessor commands will be there at the top of the C program, and it will begin with hash, and it will be like hash define or hash include, and within angle brackets we'll write some files stdio.h or stdlib.h, like that. There are different files that should be included preprocessor commands. Then we'll have functions in C. So we have the int main function. So every program will have this main function, and this will be return type. We don't need not worry about what is this int and all. We will learn about this. Then it starts with an brace, opening brace. So all the statements will be included in these two braces. So these two braces is actually the body of the program. So within these two braces, what all statements are there will form the body of the program or body of this main function. Then we will have inside this braces, we have the variable declarations. We can declare variables that will be used in the program. Then we have the body, which consists of statements, expressions, or comments. So this is a statement. This is a function, printf function. We have and it will be ended with a semicolon. Here also we can see there is a semicolon that will end that statement. And this is a command line, and this command line will be in this. We'll learn about this command line and all. I just wanted to show the structure. Then finally there will be a return statement, return 0, something will be there, and there will be a closing braces. So this is a general structure of a C program. C program, if we are including very many different functions, all those function definitions, declarations, everything will be there. So this is a simple program. This is just to show how a C program will look like. So you need not worry about the structure now. Later when you study, when you learn to write programs, you will automatically learn the structure of the C program. So C program consists of the following parts. One is preprocessor commands, then we have functions, we have seen this, variables, then statements and expressions, then command lines will be there. We'll see an example program, then you'll understand how to do this programming and all. So if you want, you can install the C program. If you are using a Linux system, you will have this GCC compiler. You can write in any editors and you can compile that code. Otherwise, if you are using any other Linux, Windows or Mac, you can go for this ID environment also. So this I have used code blocks. You can use Eclipse or Visual Studio. There are different environments available. You can download anything. So this is an open source thing. You can install in Windows or Mac or Linux system. So this is a simple hello world program. This is how a program will look like. So this is the preprocessor command hash include stdio.h. Then we have a main function here in main function and within the opening brace and a closing brace. So all together will form this main function. Then this is another command line. So I am including a command line here also, my first program in C. I am including a printf function here, and what it prints is, it will simply print, it is asking to print this hello world and an exclamation mark. And there's slash in here. We'll learn about everything later. So this is a simple program. So if you want to compile this, you can compile this, and if there is no error and all, your output will look like this. So in the terminal you will get the output hello world. So hello world will be printed. So this is a simple program to print this hello world. Okay, so we can see that hello world is being printed here. So this is a first program. Whenever when you learn some programming language, you will be doing this code first. So you need not worry about all these things now. If you are not aware of C programming language, you will learn about everything. So every C language, when you start a program, you will have this preprocessor directives. So for in this program, you are including it as hash include, and within angle brackets there is stdio.h, standard input output.h. Then we have the int main function, and it should be inside, there should be some parentheses, and inside we have some braces, opening brace and closing brace, and within these braces we have many statements. So we are simply printing this hello world. Okay, so this example, so we will see what is a token in C. Token in C. So it is the smallest individual element in a C program. So it is considered to be the smallest individual element in a program. It is the building block or the basic component for creating a program in C language. It is a basic building block or the basic component for creating a program in C language. So a token can be either a keyword, it can be a keyword. So we will see what's a keyword in this lecture itself. Then it can be an identifier. So we'll see what is an identifier also. Then it can be a constant. In the next lectures to follow, we will see about this constant and all. String literal also we will see in the next lectures that is to be followed. And operator, so we will see about different kinds of operators also in C. So all these are considered to be tokens in C, or it can be any symbol, any special characters like hash, at the rate symbol. All these symbols are considered to be tokens. So it is the smallest individual element. So we will see an example, then you will understand what's a statement. So we in the previous program we have seen a statement like this: printf, and within parentheses and within quotes we have hello comma world and exclamation mark and slash and double quotes, and we are closing with a parenthesis, and there is a semicolon. So the various token in this example, the different tokens are, we will see the different tokens. Printf, this is one of the tokens. Then this braces, this is a special character, so this is a token. And this whole together is another token, we call it as a string literal, so this is a token. And this closing parenthesis, this is also a token, and a semicolon is there to end the statement, so this is also a token. So these are the different tokens in a single program itself. So if we see this program, we have different tokens. This hash include, this angle brackets, everything is a token, or int is a token, main is a token, this braces are token, sorry, this brackets, this parenthesis, this braces are all tokens. So this command line is also a token. So everything is considered to be a token in C language. Okay. Then why do we require the semicolon? So semicolon is a statement terminator in C. So every statement should end with a semicolon. So each individual statement must end with a semicolon. So it indicates the end of one logical entity. So actually when he designed this free programming language, he had included a semicolon at every statement. Those who have studied Python and all, you can see that there is no semicolon and all to end a statement. But in C language, there is a semicolon that shows that it to end that shows to that it is used to indicate the end of one logical entity. So if we see this example, printf hello world, we have a semicolon here, the previous example. And also after return 0, that's also another statement we have to end with a semicolon. So all statements should end with a semicolon. So you can see the program here. Here after this hash include std attach, it's not a statement. It's a preprocessor directive or preprocessor command. So there is no semicolon. And this is a function call. So there is no statement. Sorry, this is a function, so there is no statement, so there is no semicolon here, but in these two statements there are semicolons. Then comments. So comments are like helping text in your C program. It is like some helping text or some notes that can be included in the C program. If you see this program, this is a command line. The first line is a command line. Usually we will give some header here. So this is to show that this is actually a helping thing to the programmer. So if somebody else opens this program, he will understand what this program is. This is actually my first program in C. You can include other comments also if you want. You can say that this program is to print hello world, like that. You can include any comments inside this. So it should start with a slash, forward slash, and an asterisk, and you can write anything, and it will close it like this with a asterisk and a slash. And inside the programs also you can write these comments like this. So comments are actually helping text in your C program, and this will be ignored by the compiler. So when you compile this program, when you compile here, this is a compilation thing. When you build this program, build this actually compilation. So these statements will be ignored by the compiler. They won't take these statements. So whichever statements which starts with this thing and ends with this thing will be ignored. So you can have multiple statements also. If you want, you can have multiple statements like this. You can include in multiple lines also. It's not at all a problem. So all these, the starting and ending will be together, will be considered, or within inside all these things will be considered as comment. So when you run this program, all those programs will be all those statements will be ignored. Okay, so these are comments. Okay, so it will be ignored by the compiler, and it starts with this thing slash and an asterisk star, and terminate with the characters asterisk and a slash, forward slash. So this is an example for a comment. So this is an example. So it starts with this and ends with this. So anything can be included inside this, and it will be totally ignored by the program. And we cannot have comments within comments. So inside this comment we cannot write another comment. So that's the thing. Inside this we cannot write another comment. You can write comment anywhere in the program, and do not occur within a string or character literals. So we'll learn about the string or character literals later. So then you will understand what this is. So if I want to include this comment, if I want to, I can include it anywhere. So after this statement, if I want to include, I can include it here. Then there is no problem. If you want to include here also, you can include. The only thing you have to start with this and end with this thing. Okay. So it do not occur within a string or character literal. So we will see what is string literal and character literal. So within that, so you can consider in this, inside this double quotes, whatever you include in double quotes, it is considered to be a string literal. So you cannot include a comment inside this double quotes. So you'll learn about string literal later. Don't need not worry about that thing. Then what is this white space in C? So it is a line containing only white space, possibly with a comment, is known as a blank line. So if you see this program, this is a blank line here. So in line number 7, we have not written anything. Or line number 10, we have not written anything. Or if you see this, there are different blank spaces between this return and 0. There is a blank space. So all these are int and main, there is a blank space. So these are known as white spaces. Line number 10 is known as a white space, or line number 7 is also known as white space. Anything in between this is also considered as white space, or return, and after that there is a space. So this is known as white space. A line containing only white space, possibly with a comment, is known as a blank line. C compiler totally ignores such kind of white spaces. So in Python and all, so that white space is important, but here it totally ignores it. So it's actually white space is a term used in C to describe all this thing: blanks, tabs, new line character. We'll see about new line character. So this slash n is actually a new line character. We'll learn about this later. Yeah, and comments, all these are considered to be white space in C. So all these white spaces will be ignored by the C compiler. So you can write, you can include any spaces there. So it also separates one part of a statement from another statement. So, and it enables a compiler to identify where one element in a statement ends and the next element begins. So actually it tells a compiler. So there is a space means it tells a compiler. So int is some word, or main is some other word. So it tells the compiler that it is int is t is the end of the previous thing, and m is the starting of a new thing. Then this is an example for white space. If you see this int age, so it is actually a declaration of age. You can see a white space after int and between int and age, t and a, there is a white space. Then if you see this fruit equal to apples plus oranges, so if you see there is a white space after this. This is another way to write this comment, even though I have not shown this thing. You can include this comment like this. After double slash also you can write something, but you cannot write it in multiple lines. You have to write it in single line itself. You need not worry about this thing. Actually, in C++ and all, you might have used this thing if you have learned this. So double slash can also be used as white spaces. So between this operator also we can have the spaces, white spaces between this s and plus and o, there is some white space. Next term in C is the keyword. So there are 32 reserved words in C. So these words cannot be used by users for their variables. So we'll see what is variable identifier and all later. So there are some reserved words that is already defined in the C compiler. So it cannot be used as constants or variables or other identifier names like function names. All these are considered as identifiers. So we'll see what is an identifier in this lecture itself. So these keywords cannot be used as constants or variables or any other identifiers. So these are there are 32 reserved words in C. So these are the different reserved words in the C. So when we start writing programs, we will be using almost all these words when we write the C program. So it is already included in the C program. So in the previous program, we have seen this int was there. Then you can see this int. Then only we have already only seen this int keyword. No other words we have not seen any other thing. So int we have seen this. So this is a keyword. So like this, there are 32 different keywords: auto, double, int, struct, break, else, long. So these are reserved words. So users cannot use this for defining their own constants or their own variables or any other functions or any other thing. They cannot use these words. So these are actually reserved keywords. So we'll understand this when we write C programs. Then we'll see what is an identifier. So it is a name. Identifier is a name used to identify a variable, function, or any other user-defined type. So it's like a name. So if you want to identify a particular person, we will have a name, maybe Anne John. So it is a name given to a person. So when we call Anne John, will understand, a picture will come to your mind that that person Anne John will be there. Like that, similarly, we need to identify a variable. We will see what is a variable in the next lecture. Function we will be seeing later, or any other user defined items are there. So for all those things, we need to name that. So that thing is known as identifier. So user defined names. So identifiers are actually user defined names which consist of alphabets, number, and underscore. That underscore will be there. So this dash underscore. So keywords cannot be used as identifiers. So we have already seen the 32 keywords. Those keywords cannot be used as identifiers. So there are some rules for naming C identifiers. So it must always begin with alphabets or underscore. That is, you can either begin with capital A to Z, any of the characters or alphabets, or small a to Z, any of the alphabets, or you can start with underscore also, and it is should be followed by 0 or more letters. Maybe you will be simply saying A. A itself is an identifier. Or we can include ABC like that, AB123 or ABC underscore 123 like that you can include. So will be followed by 0 or more letters, underscores, and digits can also be there, like A95, A25 like that you can include. So all those will be considered as identifiers. So only alphabets, numbers, and underscore can be used to name this identifier. No other special characters or punctuations are allowed when you use this identifiers, and it must not contain white space. So between this we cannot include white spaces. So for when you use an identifier name, if you cannot include a white space in between this identifier, and it should not be a keyword. So we have already seen the 32 reserved keywords. So identifier names should not be any of those 32 keywords also. And it should be up to 31 characters long. In some compiler there is a restriction, so it will take only up to 31 characters. So if we are making more than 31 characters, it will take only up to 31 characters. So usually we'll be giving some 10 or 15 character name, or maybe 5 characters like that. C does not allow punctuation characters such as at the rate symbol, dollar, percentage within identifiers. So we cannot include these symbols within this identifiers. And C is a case sensitive programming language. This is also important. The uppercase and lowercase, there is a distinction in C programming language. So manpower is different from this manpower because here M is capital and here M is small letter. So both these will be considered as two different identifiers. So this is another example for an identifier, MOSD, Muhammad or anything, MOSD. This is an identifier. It starts with a letter and it is followed with 0 or more letters. And this is another identifier. It starts with an alphabet and it is followed by 2 or more, 0 or more characters. This is another identifier, ABC. And this is also an identifier. We have an underscore in between. There is no space in between. It starts with an alphabet. This is also a valid identifier. It starts with an identifier, then it is followed by an underscore, and digits can also come 1, 2, 3 like this. This is another identifier, my name 50. This is also, we can use this for identifying variable or anything, my name 50. Or this is also considered an identifier because it can either start with alphabet or underscore. We cannot start with digits, but we can start with alphabet or underscore. So this is also valid. So there is no space in between. If there is a space, then it is invalid. Okay, there is no space. There should not be any space between P and J. Actually, I think there is some space here. So if there is space, it is not a valid identifier. Then this is also a valid identifier, A23B9. This is also identifier. So it starts with alphabet and it can have digits or alphabets after it. This is another identifier, ret val. It's also an identifier. So it's capital letter V is used. You can use capital or small letters also. Then we will see some invalid identifiers. This is invalid because it starts with the digits. We cannot start an identifier with a digit. So this is an invalid identifier because char is actually a keyword. It is a reserved. It is one of the 32 keywords in C. So it is a reserved word. We cannot use this as an identifier. Then x plus y, it is not an identifier because plus, it is a symbol. So we cannot include symbols inside an identifier. Special character. So this is a special character. Then my dash underscore name. This is not an identifier. This is actually dash. This is not underscore. So this is not an invalid thing. So we have a special character there. Then even number. This is invalid because there is a space between these two n. We should not have spaces or white space between in between these characters. So that's all about identifiers. Thank you.